Today, we know them as massive nuclear furnaces, burning billions of miles away. But what if our modern understanding is incomplete? What if some distant lights are not just natural balls of gas, but colossal, artificially constructed engines powering unimaginably advanced alien empires? Today, we embark on a journey into the realm of the ultimate cosmic megastructure. It is a concept so mind-bending, so vast in its scope, that it blurs the line between science fiction and our inevitable cosmic destiny. We are talking about the Dyson sphere. We will explore how an expanding species might literally dismantle entire planets to construct a magnificent swarm of solar collectors designed to capture the total energy of their host star. This is the epic story of how a civilization transitions from planetary mortals to masters of the cosmos. To comprehend the necessity of such a titanic undertaking, we must look at the relentless march of technological progress. As any civilization advances through time, its hunger for energy grows at an exponential rate. Every technological leap, from the mastery of fire to splitting the atom, demands a heavier toll on the resources of its home world. Eventually, an inescapable threshold is reached. The planetary cradle becomes too small. Its resources are proven dangerously finite, and ancient, fossilized sunlight, buried underground, is utterly insufficient for the soaring ambitions of a spacefaring species. A growing empire needs an energy source that is virtually infinite, reliable, and capable of sustaining billions of years of continuous progress. Where does a civilization look when its planet runs dry? They look up. They look to the ultimate nuclear reactor, sitting silently in the center of their solar system, their star. The incredible concept of this ultimate stellar harvester did not begin in a laboratory, but in the boundless imagination of science fiction. The foundational idea was first eloquently articulated by visionary British author Olaf Stapledon in his 1937 novel, Star Maker. Stapledon described a magnificent universe heavily populated by advanced species who constructed gossamer webs of artificial habitats surrounding their stars, designed to trap every escaping photon of light. This poetic vision of cosmic engineering planted a seed that lay dormant for decades, waiting for the right mind to transform it into a rigorous scientific hypothesis. Fast forward to the year 1960, the dawn of the space age, a time of boundless optimism and Cold War tension. During this era, brilliant, unconventional theoretical physicist Freeman Dyson published a short, provocative paper in the prestigious journal Science. Dyson's paper, titled "Search for Artificial Stellar Sources of Infrared Radiation," fundamentally changed how astronomers think about the search for extraterrestrial intelligence. Dyson argued, with inescapable mathematical logic, that any civilization surviving long enough to master its environment would inevitably require the total energy output of its parent star. He calculated that humanity's energy consumption was increasing so rapidly that within just a few thousand years, we would need to capture a significant fraction of the sun's total power. Dyson postulated that an advanced alien species would systematically construct a vast system of orbiting structures completely surrounding their star to catch its radiation. This concept immediately captured the public's imagination and was permanently christened the Dyson sphere. To grasp the staggering magnitude of this concept, we must place it within the Kardashev scale, a method proposed by Soviet astronomer Nikolai Kardashev in 1964 to measure a civilization's technological advancement based on its energy consumption. The Kardashev scale envisions three primary tiers of cosmic civilizations. A Type 1 civilization has successfully mastered all the energy available on its home planet, fully controlling its weather, earthquakes, and oceans. Humanity is currently hovering around a Type 0.73, still reliant on dead plants, and struggling to manage our climate. A Type 3 civilization is an incomprehensible empire that commands the energy of an entire galaxy. But the crucial stepping stone, the great filter of cosmic history, is the Type 2 civilization. This is a species that has successfully harnessed the total energy output of its host star. Building a Dyson sphere is the ultimate graduation project, the defining hallmark of a true Type 2 civilization. The sun releases energy at a rate of roughly 400 septillion watts every single second. It is an amount of power so vast that it exceeds the combined explosive force of billions of nuclear weapons detonating simultaneously. Now, let us dispel the most common, enduring, and scientifically inaccurate misconception about the Dyson sphere. Driven heavily by popular media and science fiction illustrations, many people imagine a Dyson sphere as a perfectly solid, rigid, unbreakable shell, completely enclosing a star. From a physics-based perspective, this solid shell model is practically impossible. A rigid sphere would be subjected to utterly catastrophic gravitational stresses. Furthermore, it would have no orbital stability. Without a massive central structure anchoring it perfectly, any slight nudge from a passing comet or a minor gravitational perturbation from a neighboring gas giant would cause the massive shell to inevitably drift, crashing horribly into the star it was built to contain. No known material in the entire universe possesses the tensile strength required to hold such a monstrous solid structure together. Instead, Freeman Dyson himself actually envisioned something far more elegant, modular, and dynamically stable, a magnificent shifting architecture known as a Dyson swarm. A Dyson swarm is a breathtakingly dense, highly choreographed constellation of millions, perhaps billions, of independent orbital structures. These could include massive solar collectors, intricate zero-gravity manufacturing facilities, and vast rotating cylinder habitats, holding trillions of citizens. Each individual component of the swarm would have its own specific calculated orbit around the star. They would weave around each other in a deeply complex orbital ballet, carefully managed by supercomputers to prevent catastrophic collisions. This modular approach is infinitely more practical. A civilization could build the swarm incrementally over thousands of years, starting with a single, highly efficient solar satellite, and gradually multiplying their numbers. But how exactly would an expanding empire go about constructing such an impossibly vast, mechanical swarm? The sheer volume of raw material required is enough to make a planetary engineer's head spin. You cannot simply mine a few asteroids. To build a robust Dyson swarm, a civilization would literally need to dismantle entire planets. Imagine a highly coordinated fleet of millions of autonomous, self-replicating robotic probes descending upon the scorched, heavily cratered surface of a planet like Mercury. Because of its extremely close proximity to the Sun and its high metal content, Mercury is the absolute perfect candidate for a cosmic demolition project. These advanced drones would methodically, relentlessly strip the planet apart, layer by rocky layer. The extracted iron, titanium, and silicates would be magnetically launched into space, using massive mass drivers built directly into the dying planet's crust. In orbit, autonomous foundries would melt and forge this raw material into incredibly thin, highly reflective solar sails and complex solar panels. As the centuries turn into millennia, the planet Mercury would slowly disappear, completely transformed into a brilliant, glittering ring of mechanical mirrors orbiting the Sunday. Over more millennia, this ring would expand, encompassing Venus, perhaps even Mars, slowly dimming the light of the central star. The profound consequences of successfully completing a Dyson swarm are difficult for the human mind to fully process. A civilization wielding the unleashed power of a star could bend the very fabric of space and time to their will. They could power supercomputers the size of entire moons to run highly realistic simulations of the universe. They could generate massive beams of concentrated energy to propel armored starships to neighboring star systems at a fraction of the speed of light. Furthermore, they would essentially become immortal, totally immune to the sudden extinction events that routinely threaten fragile, planetary-bound species. But this brings us to a deeply thrilling realization. If these incredible megastructures truly exist out there in the vast darkness of the cosmos, we might actually be able to detect them. As Freeman Dyson pointed out, no technological process can ever be completely efficient. The laws of thermodynamics dictate that some energy must inevitably be lost as waste heat. Therefore, a Dyson swarm, absorbing the intensely hot, visible light of its parent star, would inevitably radiate a tremendous amount of low-grade waste heat into deep space. To an observer looking through an advanced infrared telescope, the star would appear unnaturally dim in the visible light spectrum, but fiercely glowing in the deep infrared spectrum. This specific artificial infrared signature is exactly what modern astronomers and the search for extraterrestrial intelligence are actively hunting for today. This tantalizing search actually leads us directly to one of the most fascinating and highly debated astronomical mysteries of the 21st century. In the autumn of 2015, the scientific community was sent into an absolute frenzy. The Kepler Space Telescope discovered something bizarre. A distant star, affectionately known as Tabby's star, was violently dimming. Its light plummeted by a staggering 22% in highly irregular chaotic patterns. Something colossal and asymmetrical was passing in front of it. The internet immediately exploded with a hypothesis: had we found a Dyson swarm in construction? While subsequent observations point towards a massive cloud of cosmic dust as the likely culprit, the fact that astronomers entertained the megastructure hypothesis demonstrates how the concept of the Dyson sphere permeates our search for cosmic neighbors. Whether we find them tomorrow or discover we are alone, the Dyson sphere serves as a profound mirror. It reflects our ultimate potential, challenging humanity to look beyond our blue marble and engineer the heavens. The universe is vast, ancient, and waiting. The only question is whether we will survive long enough to claim our place among the stars. Please like, comment, share, and subscribe to the channel